When we're dealing with linear functions, the equation is always going to look like this. Y is equal to mx plus b. At least we always want it to look like this because this equation is very easy to read. Let me show you. So this letter m actually stands for the slope, and the letter b is just the y-intercept. Okay, the y-intercept is the point on the y-axis where it crosses. So this one's y-intercept is -4, so it crosses right there. That's where the line is going to cross the y-intercept. So when we fill in these numbers, we're going to see our equation is y, actually I'll write it in here, y is equal to 1/3 x, right? We filled in m, plus b. But see, our b is a -4, so if you're adding a negative number, it's the same thing as just subtracting. So y is equal to 1/3 x minus 4. And that's going to be our equation. So that's always how you write the equation, is you just fill in the slope for m, and you fill in the y-intercept for b. So it's y is equal to mx plus b. Now, if we wanted to plot this, there's a few different ways we can do it. The first way we can do it is we can make a table of values. So what we can do is say, okay, we're going to go from -3 to 3. So -3, -2, -1, 0, 1, 2, 3. All we're doing is filling in this x value into this equation, which will give us y. So we're going to say, okay, well, if we want this y value, y is going to equal 1/3 x minus 4. And if we fill in the x value, so 1/3, and then we're going to fill in -3 minus 4. So that's just going to equal -1 minus 4, which is equal to -5. So our y value here is -5. Now we can do the same thing for each of these numbers. So we'll fill in the -2 into the equation, and what I got was -4.67. And if you fill in -1, I got -4.33. And if I fill in 0, I end up with just -4. I'll show you this one. So y is equal to 1/3 times 0 minus 4. 1/3 times 0 is just 0, so that's going to just equal -4. If we fill in a 1, we're going to get 3.67. If we fill in a 2, we're going to get -3.33, and sorry, this is a negative as well. And if we fill in a 3, we're going to get -3, and I can show you this one as well. So if we filled in the -3, we get 1/3 times 3 minus 4, right? All we're doing is filling this first value into our equation. So that would be then 1 minus 4, right? Because 1/3 times 3 is 1. So 1 minus 4 is equal to -3. And we just fill it in there. So all we have to do then is plot these points. So each of these is just a point with an x and a y value. So let's plot this one first. -3, -5. So we're going to go 1, 2, 3, 1, 2, 3, 4, 5. So there's our first point. We can plot this point, so -2, -4.67. So we're going to go -2, 1, 2, -4.67. So 1, 2, 3, 4. 4.67 is going to be somewhere around here. Okay, it doesn't have to be perfect. Our next point is -1, -4.33. So -1, -4.33, somewhere around there. Then as you can see, we're plotting a line. And then we have our y-intercept, 0, -4. Then we have our next point is 1, -3.67. So 1, -3.67 is down here somewhere. Then we have 2. See, all I'm doing is plotting these points. So I started up here, kept on going down. Now we're here, so 2, -3.33. So we go to 2, -1, 2, 3. 3.33 is probably somewhere around here. And then our last point is 3, -3. So we're going to go 3, -3 right here. Now we could extend this and keep on plotting for 4 and 5, but we don't really need to at this point because we have our line. So we can just kind of draw, and with a ruler, you should be doing this on your sheet, we can draw a line through there. So that's what our line is going to be. So for this one, let's do a little bit of an easier method. We know we can write our equation because we need to have y is equal to mx plus b. So y is equal to negative 4/3 x plus b, and our b is just negative 1, so we're going to say minus 1. So there's our formula, or our equation. So this one we're going to do a little bit of an easier method. So the y-intercept actually is just the spot where it crosses the y-axis. Okay, that's a very easy point to plot because it's going to cross the y-axis at y is equal to negative 1. So we just plot that, and then we can look at our slope. Okay, if slope is equal to rise over run, then we know that our rise is going to equal negative 4 and our run is going to equal 3. So if we go from this point, which we know is a point on the line, we know that we're going to have to rise negative 4. So we're going to have to go down 4. 1, 2, 3, 4. And then we're going to have to run 3. So 1, 2, 3. So there's our next point. Now, we can see that our lines are going to be going like this. We need another point though on the line. So let's go backwards. So if we're going backwards, we want to plot a point up here because our line's going to be going like this probably. We want to go backwards, we do everything the opposite. So instead of going down 4, we're going to go up 4. 1, 2, 3, 4. And then we're going to go to the left 3. 1, 2, 3. So then there we are. We have our line, and it goes like that. And it's actually going to extend all the way up as well. And so that is actually a really easy way that you don't have to plot a bunch of points. You can just plot the y-intercept and then run off of that with the slope. Use the slope to figure out where another couple points are, and then you can just draw your line. Let's do another example. So let's write our equation. So we know we need y is equal to mx plus b. So y is equal to our slope, so negative 1 times x, and then b is 3, so plus 3. So we know, since our y-intercept is 3, we know the line is going to cross right there. Okay, that's what y-intercept means. Now we can use these to very carefully plot our line. We don't even have to do a table because we know that if our slope is equal to the rise over run, then this slope is going to be negative 1 over 1. Because if you just have a slope that's a number by itself, it's actually over 1. So our rise is going to be negative 1. So it's to the right, it's going to go down 1, and then it's going to go over 1 because our run is 1. So it's going to go there. And it's going to keep doing that. So our rise is negative 1, so we go down 1, and then we go run 1 to the right. So we just keep on doing that, and we can actually go up from the y-intercept because we know that the next point, it's from here to here, it's going to go down 1. So we can actually say, okay, when we go backwards, we're going to go to the left 1 and then up 1. So we left 1, up 1 when we're going backwards from the y-intercept. So then we actually have our line right there.